how can we describe the projectile motion of a soccer ball? We see the ball follows an arc path through the air until it hits the ground. Let us separately observe the vertical and horizontal components of this path during constant intervals of time. Notice the horizontal distance traveled in any time and opposed to the same. Notice that the vertical distance varies with time exactly as seen in the ball thrown upward the same initial vertical motion. We can see that the path of the ball consists of independent horizontal and vertical components which can be mathematically combined to describe the ball's trajectory.
If we think about the motion of all of those things, their movement is actually a combination of two movements. An upward and downward movement. The ball goes up in the air and comes down again. The water goes up in the air and comes down again. So there is an up and a down movement, but there is also a long movement. The ball travels through the air horizontally. And the final path of the ball or the shell or the water is a combination of the vertical movement and the horizontal movement. So, if, for example, I kicked a ball straight up in the air, it would go up and down again. Only vertical movement. But if I kick a ball at an angle, it goes up and down, but it also moves along. And the result is a path like that. And you'll remember, I've already said, the path of that ball is a parabola. That's the shape of this curve. But what I want to emphasize now, that curve, that movement of the ball is a combination of a vertical movement, up and down, and an along movement. Now, there's something really important to understand. The vertical movement is totally independent of the horizontal movement. The vertical movement is totally independent of the horizontal movement. It's difficult to accept that, but it's true. The fact that the ball is moving along does not affect the way in which it moves up and down. And in fact, if you can imagine somebody kicking a ball like that, and at exactly the same moment somebody kicks a ball straight up into the air and it goes to there, same height and back, then at any given moment, if I were to take photographs of the two balls, they would be going up and down exactly together. They would go up and down. This ball would hit the ground again at exactly the same moment as this ball hits the ground. Now I'm going to say all that again because it's difficult to accept that. If the ball is kicked like that, and at the same time a ball is kicked vertically upwards, the movement up and down of the two balls is the same. If I could take snapshots at different time intervals, I would see that this ball reached the top here just when this ball reached the top there. And then they fall down again together. This ball, up and down, hits the ground at exactly the same moment as this ball hits the ground. But the point is, this ball has also got a horizontal movement. So as well as going up and down, it's also moving this way. And if we think about the time taken, you may not believe it, but I said this ball going up and down there hits the ground at exactly the same moment as this one. This one has gone a much bigger distance, but they take the same time. to go up and down like that as to go like that. I'll repeat that. The time taken for the ball to go up and down like that is exactly the same as the time taken for this ball to go up and down like that. But this has travelled a horizontal distance because this had a horizontal movement given to it. So, if we think about what we have learned in school about the laws of motion, we know that if that height is s, that the time taken for a ball to fall freely under gravity, a distance of s, is given by the formula s equals a half g t squared, where s is the distance it falls, g is the acceleration due to gravity, 9.8 meters per second, and t is the time taken for the ball to fall. So that's if I release a ball here and it drops to the ground, I have this formula which determines its movement. This formula also applies to the vertical movement of this ball. So this ball's going up and down, and the time taken for the ball to come down, this half of the trajectory, is again given by s equals a half gt squared, where that height equals s. Now, think about it. If it took 2 seconds for the ball to come down here, because it's equal on either side, it takes 2 seconds for it to get up there. So 2 seconds up, 2 seconds down. So if I measure how long it takes for the ball to get from here to here, how many seconds, and halve it, that's the time taken, t, for the ball to fall down. Just as it's the time taken for this ball to fall straight down. If therefore I kick a ball and measure the time taken from kick to hitting the goalkeeper and then halve it, that tells me how long it took for the ball to fall. I put that half time into here, and that tells me how high the ball went. You've probably learned in school you can measure the height of a building by dropping a ball, a little lead ball, measure how long it takes to hit the ground, and that is the t. G we know, so you can work out how high the building was simply by dropping a ball. Now, a bit of theory there, but let's look at another very good example of projectile motion. And so here we are at the National Archery Ground in Changlimitang in Thimphu. I think a traditional bow here. If somebody can give me a traditional bow. I hasten to add that I'm not going to fire it. The last time I fired a bow was 43 years ago in Paro, and you know, with traditional archery it's customary that the other team dance in front of the target to try to put you off when you're firing the bow. Well, I was so bad at archery, nobody had any idea where an arrow that I fired would go, and so the other team, instead of dancing in front of the target, they all used to emit very, very loud screams, and they would run miles away from the target in order to put me off and make me feel humiliated. So I'm not going to attempt to fire this bow. However, traditional bow and a compound bow. So we've got here the traditional bamboo bow, which has served Bhutan very well for hundreds of years. And I need hardly tell you, the arrow gets the energy from stretching the string, which causes the bamboo to bend. So we've got elastic energy there, which when you release is then turned into kinetic energy of the arrow. Now, the bamboo bow has got a particular characteristic. That is that when you've pulled it to its full extent, you've got to use a very big force, and it's quite tiring to hold. Can you pull it a bit more? And to have to hold it there and aim is quite exhausting. So when you're firing a bamboo bow, you pull it back and then very quickly you let the arrow go. One problem solved is the force you need to hold the string out, and that's solved by having a compound bow. And if you look at the top here, you'll see that instead of the string just being attached to the material, the string actually goes over a little pulley there. Now watch what happens to that pulley as the string is stretched. Watch the pulley. It rotates. It rotates. And the way in which it rotates means that once you've pulled the string of the compound bow out fully, the force you have to use reduces. This means you can hold it for a longer time in order to take aim before letting go. Now, it also means that you can get a much bigger force onto the arrow. So a compound bow arrow travels much faster than a traditional bow arrow. So if I could just use this in a rather strange way, let's pretend you're firing the bow. The arrow from a traditional bow comes out more slowly because the force is not as great. And so because it travels more slowly, you have to aim it up a bit, and the path of a traditional bow's arrow is like that, up and then down, because it's going more slowly. A compound bow arrow travels much faster, so it doesn't have to go as high. It goes like that, much faster, spends less time in the air, and it doesn't go as high. Now what this means is, and I'm sure I'll annoy some compound bow experts, what this means is that actually the skill required to hit the target with a traditional bow is much greater than the skill required to hit the target with a compound bow. Why? Because this one goes slower. It spends more time in the air. The path is like that, not so direct. It spends more time in the air, and so it's more affected by the wind. So a compound bow, where the arrow goes much more quickly, spends less time in the air, doesn't go as high, less time in the air, and less wind effect. So I believe, although some people will, I'm sure, disagree with me, it requires much more skill to be good with a traditional bow than with a very, very expensive compound bow. I mean, this is, after all, why people pay a lot of money to buy a compound bow, because it's more accurate. And if you are hunting with a compound bow, then you want accuracy. However, we're going to fire the traditional bow because the arrow goes slower. So thank you, compound bow. Let's send that away. And now let's ask our friend here to fire the arrow. Now, do you remember I said when the arrow comes out like that, it's moving up and it's moving along. And the upward motion is totally separate from the along motion. The actual path is a combination of the two. Let's get him to fire it quite high into the air. Now, watch it when it goes up in the air and down. Now, if you could try and fire the arrow more vertically, taking care it's not going to land on your own head, then if we measure the time from when you release the arrow to when the arrow hits the ground, if we measure the time with a stopwatch in my mobile phone, then we can measure how long it took for the arrow to go up and down. And if we divide that time by 2, halve it, that'll tell us how long it took the arrow to fall. And remember, S equals a half g t squared. We've measured t, we know what g is, so we can work out how high the arrow went. So I'll get somebody to operate the stopwatch. You fire the arrow straight up in the air. Mind you don't hit anybody or hit a dog or anything like that. As vertical as you can. So we fired the arrow went up and down. It went almost vertically, approximately vertically, but not quite, otherwise the person firing the arrow would be dead. So it went up and down. The total time up and down was measured at 4.95 seconds. Well, 4.95 is approximately 5 seconds. You know the equal sign with a dot above and below means approximately equal to. So the time up and down, about 5 seconds. So the time up and down, if we divide it by half, if we take half of it, we'll get the time up or the time down, because it takes as long to go up as to come down. So a half of 5, 2.5 seconds, is the time taken for the arrow to fall. 2.5 seconds to fall. Now, the formula you'll have learned at school, S equals a half gt squared, tells us that if it took 2.5 seconds to fall, we can work out S, the height that it fell, from this formula, a half gt squared, which gives us a half, multiplied by g, 9.8 meters per second, the acceleration due to gravity, multiplied by 2.5 seconds squared. Now, 9.8 is nearly 10. So let's do another approximation to simplify the calculation. So this approximately equals a half multiplied by 10 multiplied by 2.5 squared. So a half of 10 is 5, multiplied by 2.5 by 2.5 gives us 5 multiplied by 6.25. When we multiply 5 by that, we get that, which is approximately 30 meters. So we can work out, simply with a little stopwatch, that our arrow rose 30 meters into the air and then fell 30 meters. So, next time you come to watch an archery match, bring a stopwatch with you, and you can see how high the arrow goes. Now, we're going to fire the arrow now, not vertically up, but at an angle, and see what we get from that. We just looked at the arrow being fired almost vertically up into the air. But what actually happens if we want it to try to get towards the target, we actually fire it at an angle. So I just want to look at the arrow now being fired at an angle between vertical and horizontal. If you would do that, and again, we're going to time how long it takes for the arrow from leaving the bow to hitting the ground. So stopwatch ready? Right. So now, that time, instead of firing the arrow straight up as before, and it came more or less straight down, we actually fired the arrow at an angle. So we gave it vertical velocity, and we also gave it horizontal velocity. The horizontal velocity makes it move steadily this way. The vertical velocity makes it go up, turn round, and come down again, except, of course, it's coming down here. We can do exactly the same sort of calculation as before. My stopwatch operator told me that the total time to go from here to there was 3.5 seconds. It took 3.5 seconds to go from there to there. So it took 3.5 seconds to go up and down again. So if we divide that by 2, we can find out how long it took for the arrow to fall. So the time for the arrow to fall was a half times 3.5, which equals 1.75 seconds. So the arrow took 1.75 seconds to fall down. Now we come to our classroom formula again. The height the arrow went up, is a half times g times 1.75 seconds squared. T, the time for the arrow to fall down. That's approximately a half times 10 times 1.75 squared, which is 5 times 1.75 by 1.75, which is 5 times 3.06. Well, we're going to do an approximation again. 3.06 is more or less 3. And so instead of making a complicated piece of arithmetic, we can just do 5 times 3, which tells us that S equals 15 meters, approximately 15 meters high. So when we fired the arrow like that, it went about 15 meters high and then down again. And it took a total of 3.5 seconds to travel that distance. So if we measured how far the arrow actually went, we could work out what the horizontal velocity was, and we can calculate how high the arrow went. Now, of course, that was only a very little bit of firing. Let's see if our archer can fire the traditional bow from one end of the ground to the other and actually hit the target. Maybe that's enough. So every time you watch archery, watch the trajectory of the arrow. Remember, it's a parabola. Remember, the path of the arrow is a combination of a horizontal movement and a vertical movement. The two combined give the parabola shape. Watch the flight of the arrow, easier to see with a compound bow, with a traditional bow than with a compound bow. And think about S equals a half GT squared, and think about all the formulas you've learned for projectile motion in school, because archery, the national sport of Bhutan, is a splendid example of projectile motion. Now, we just fired the arrow with a traditional bow the whole length of the archery ground, and we fired it at an angle, so its trajectory was like that, a parabola, and we measured the time from letting go to hitting the target, well, nearly the target. The time taken to go from here to there was measured as 4.8 seconds. Now, 4.8 seconds from here to here. The arrow went up and down in 4.8 seconds. So it just took half of 4.8 seconds to do the second bit, the fall. So the time for the arrow to fall is a half of 4.8, which is 2.4 seconds. Now, if we use our school formula S equals a half GT squared for a falling object, falling freely under gravity, we've got S, the distance it fell, is a half times G times 2.4 squared. Well, let's do our approximating again. That's about half times 10, because 9.8 is almost 10, multiplied by 2.4 squared, which is 5 times 2.4 squared, which is 5 times 5.76, which gives us 28.8 meters, so about 29 meters. So when we fired the arrow from one end of the archery ground to the other with a traditional bow, the arrow went up into the air about 29 meters. So that's quite high. And it took 4.8 seconds, that is 4.8 seconds for the wind to be able to blow the arrow sideways. So that's why firing a traditional bow, you have to be much cleverer than firing a compound bow. So we know the arrow rose 28.8 meters high, but also we know that the length of the archery ground between targets was approximately 145 meters, and it took 4.8 seconds. So now we can do a simple calculation. It took 4.8 seconds to travel a horizontal distance of 145 meters. So what's the horizontal velocity of the arrow? The arrow goes like that, which is a mixture of an upward motion and an along motion. So what's the along or horizontal velocity? Well, distance 145 meters, time 4.8 seconds, velocity equals distance over time, which gives us the answer of about 30.2, say 30 meters a second. So the horizontal velocity of our arrow, when we fired it like that, it was moving along at a velocity of about 30.2 meters a second. Now, you can also use your simple school formulas to work out what the vertical velocity was. How quickly did the arrow go up? What was the velocity upwards with which the arrow left the bow? And to do that, I've just done a quick calculation here. We don't want to labour it too much. We'll use one of our school formulas, v squared equals u squared plus 2as. V is the final velocity of the arrow when it goes up. Well, the final velocity is 0, because the arrow goes up, stops, and then it comes down again. I'll repeat that. The arrow goes up, stops, and then comes down again. And so our final velocity v is 0. V squared is 0, so we have 0 equals that. We rearrange the equation, we get, put this on the other side, we get u squared equals minus 2gs. The minus just indicates that gravity is acting downwards, and we can calculate, using v squared equals u squared plus 2as, that the vertical velocity of the arrow with which it was sent off from the bow is about 6.8 meters a second. In other words, the arrow went up like that with a vertical velocity of 6.8 meters a second and a horizontal velocity of 30 meters a second. And the final path of the arrow is a combination of these two velocities. Well, now, sounds terribly complicated with all this arithmetic, but the point is, anybody who plays archery and can get that arrow near the target hasn't done all these calculations. Can you imagine in an archery match, everybody with their pocket calculator doing all these calculations to work out what angle to fire the bow, how far to pull the string, and all this sort of thing? No, because one of the things about learning to play archery is that you develop an internal understanding of projectile motion without going to school. An old farmer in the village who's never been near a school can be very, very good at archery because they understand from experience and common sense the movement of the arrow. They don't know what a parabola is, but they know the shape of the path of the arrow, and they can calculate how far to pull the string of the bow to give the correct velocities, and they can calculate the angle of the bow to give the correct combination of vertical and horizontal velocity. I said in a previous program, we all understand physics because every moment of every day of our lives we are using the basic principles of physics, but we don't always know about it. So remember what was supposed to be a motto of these programs: physics is simple and physics is fun. Somebody who plays archery has a natural understanding of projectile motion.